Hello, everybody. Welcome. Buenos días, buenas tardes, good afternoon, good morning. We will be starting in 1 minute. You are in listening mode only. If you have any questions, please write them in the chat. The way that we're going to do this webinar is that I will give a brief introduction of the Ocean Acidification Day of Action. Presenting to you today in the panelists are Dr. Jasmine Detres. She is the coordinator for the Coastal Acidification Network in the Caribbean with Cari Goose. Janet Rimmer, who is the coordinator for the Mid-Atlantic. Am I correct with that? Yes, it's just wearing the SOCAN shirt. With the Mid-Atlantic Coastal Acidification Network. Emily Hall, who's coordinating the Southeast Ocean Coastal Acidification Network, and myself. My name is Natalia Lopez. I am the Gulf of America Coastal Acidification Network coordinator. And today we have two wonderful panelists, Dr. Aurea Rodríguez, the founder and director of Taller Ecológico de Puerto Rico, and she will talk to you about what is that, and Dr. DeMarcus Robinson, who is from the NOAA AOML and Florida A&M University. He's a postdoc. You're still a postdoc? Yes? Yes, you're a postdoc, but he is a great asset. And both of them have prepared wonderful presentations about their experiences. So welcome, everybody. I will go ahead and start. Welcome, everyone. We are slowly getting attendees, but for matters of time, I'm just going to start the introduction for those who are joining us right now. My name is Natalia Lopez. I am the Gulf of America Coastal Ocean Acidification Network Coordinator. And this webinar is an effort from the Coastal Acidification Networks of the Caribbean, the Gulf, the Mid-Atlantic, and the Southeast Ocean. And today we are commemorating the Ocean Acidification Day of Action. So what is the Ocean Acidification Day of Action? So it started by the Ocean Foundation back in 2019 as part of their Waves of Change awareness campaign. This day is selected to bring awareness about ocean acidification and the decline of the global average pH from 8.2 to 8.1 over the past 200 years. And that's why 1/8 or 1/8 is the day of awareness because of that pH drop. So this change indicates 26% increase in acidity and is 10 times faster than any point in the last 300 million years. And it highlights ongoing efforts to understand, mitigate, and adapt to the impacts of ocean acidification on marine ecosystems, coastal communities, and their economies. If you'd like to see and learn more about what the Day of Action is and more of the NOAA acidification program, they have prepared a wonderful web story that you can scan in this QR code. I will leave it up for just a couple of minutes. And there are a lot of resources also in the OAP web page as well. And you can just type in any search bar, NOAA Ocean Acidification Program. So as part of the ocean acidification programs, there are the coastal acidification networks. And these are the many networks that we have, and I've just highlighted with arrows who are collaborating on this webinar today. And so coastal acidification networks are regional networks that from diverse ocean users that are interested in addressing ocean and coastal acidification in the United States. And they play a critical role in supporting regional monitoring, community engagement, and capacity building. So more so like we are the connection. We are here to provide the connections, the collaborations between the coastal acidification networks and the different end users and stakeholders that are doing monitoring of either water quality or other parameters in the ocean. And we are facilitators, as I like to say. So the CANs work at the intersection of science, policy, industry, and education and outreach. They bring together researchers and state agencies as well as educators like we've brought to you today to leverage expertise and collectively address common challenges and develop locally relevant adaptive strategies to ocean acidification. And without further ado, we have invited two wonderful speakers. We have Dr. DeMarcus Robinson and Dr. Aurea Rodríguez Santiago. Dr. Rodriguez is a marine scientist and educator with graduate training in industrial microbiology and marine sciences from the University of Puerto Rico, Maya West. She has extensive expertise in science education across K-12, university, and community settings. She's a wonderful professor as well. She served in my master's committee and taught me a lot about zooplankton. But also, she is the founder and director of Taller Ecológico de Puerto Rico, and she will talk to you more about those efforts today, where she has provided support, education support to agencies like CARICUS and the NOAA NERS, the National Estuarine Research System, as well as other local stakeholders such as the Department of Natural and Environmental Resources of Puerto Rico. And Dr. DeMarcus Robinson is a biogeochemical oceanographer and a postdoctoral research associate at the NOAA Center for Coastal and Marine Ecosystems at Florida A&M University. His research interests include coupling biogeochemical dynamics between the benthic and pelagic systems, the calcium carbonate geochemistry, and exploring national and international marine and climate policy. DeMarcus is current research uses otoliths microchemistry to understand how ocean acidification and deoxygenation affects red snapper, which I love for snapper, by the way. It's one of my favorite fish. So, and he received a bachelor's degree in environmental science from Florida A&M and a master's and a PhD in atmospheric ocean sciences from the University of California, Los Angeles. So without further ado, we will start this webinar. We'll kick this off with Dr. DeMarcus Robinson. DeMarcus, are you with us?
Yep, I'm here. I'm trying to get the controls together.
It's okay. We are live, everybody. All right. I will switch it off to you, DeMarcus.
Let me know if you can see the screen.
I will show it right now. You should have the control now.
All right.
All right. Take it away, DeMarcus.
All right. And thank you for the introduction and happy Ocean Acidification Day, everybody. Thank you for taking the time out of your busy schedule to be here to learn more about the work that is happening and some of the stuff that we're both doing with our respective programs and our interests. So today I'll be talking about an experience that I had last year in Malaysia with the Global Ocean Oxygen Decade Acidification Research for Sustainability Summer School, or called GOOD OAR. And so I'll be talking pretty much about that, my experience, and my relations when it comes to ocean acidification and ocean deoxygenation. But first, I would like to acknowledge, my screen. All right. First, I'd like to acknowledge GCUS and PICE for essentially sponsoring me to travel to Malaysia. Really appreciate this opportunity because it allowed me to have the opportunity to learn more about these stressors, more as coupled effects, and also be able to engage with folks from pretty much across the globe. And also want to say thank you to the folks who essentially supported this last year's summer school to continue to bring us together and to really gain these really nice experiences. So pretty much an overview. So earlier I had mentioned about the GOOD OAR. Essentially, they're two separate programs, and they're both endorsed by the United Nations Decade for Ocean Science for Sustainable Development. So the GOOD Ocean, and essentially they do the same thing. So the GOOD Global Ocean Oxygen Decade, the purpose of this is to pretty much raise awareness about ocean deoxygenation and provide mitigation and mitigation strategies when it comes to ocean deoxygenation. And this is very similar to the Ocean Acidification Research for Sustainability. And they both are led by two networks, the Global Ocean Oxygen Network and the Global Ocean Acidification Observing Network. And so what is the GOOD OAR Summer School? Essentially, it's taking these two programs and smashing them together and providing people the opportunity to really get engaged into these two concepts. By themselves, they seem to be separate, the loss of oxygen from ocean deoxygenation, or our oceans become a little bit more acidic because of ocean acidification, but essentially they go hand in hand. You can't really talk about one without talking about the other. And this GOOD OAR Summer School essentially brought together early career scientists from across the globe, grad students, doctoral students, postdocs, to talk about ocean acidification, really learn from the experts, and to really understand about our marine environment as it relates to climate change. And so this summer school was in Penang, Malaysia. And so pretty much an overview. The summer school brought together 40 students from across the globe and early career scientists from 24 countries. It involved 7 days worth of lectures. And so in total, we had about 20 to 25 lectures, ranging from ocean acidification, dynamics and couplings between biology and ocean deoxygenation, talking about ethics of science, talking about stakeholder engagement, pretty much a wide range of things as relates to us talking about these stresses, not just in the science context, but also in the social aspect and the economic aspect of these stressors, and also talking about it in context of Malaysia. It included 10 instructors. These instructors are leaders in the field who have published multiple papers talking about these two concepts that allowed us to understand what we know about the environment that we know today. Sorry, my screen keeps changing. All right, it included 3 days of field work, which is really intensive, but really fun. Practical workshops and stakeholder engagement activities. With the 40 students and early career scientists that came, we were grouped in 4 group presentations, and each group essentially went out and led their own research and pretty much got the data together to kind of create a story and talk about it at the end of the summer school. And at the end of the day, we worked hard and had a lot of fun. And so this was hosted at the Center for Marine, Center for Marine and Coastal Studies. So it's located in the northwest coast of Penang, Malaysia. So this institute is very important for Malaysia and Penang Island. What it does is it creates collaborations with other groups, other countries around Malaysia, and understanding our marine ecosystem. And so some of the research that they do here is research relating to biodiversity and conservation, mariculture, and marine mammal ecology. And so they were very much really great hosts and really get to understand some of the work they were doing, but also really having an opportunity to understand the culture of Malaysia and really be able to engage in those opportunities. And so pretty much the rest of this talk is structured in this way, lectures, then talking about field samplings and stakeholder engagement. So going to the lectures, like I had said earlier, we had a wide range of lectures, and this is pretty much the overview of the topics, which doesn't include every single lecture itself. And you can see that the topics range from just simple introductions of both ocean deoxygenation and ocean acidification to talking about its interactions with the physics and biological setting of the marine environment, more specific when it comes to Malaysia. I'm talking about data management, and then going to other topics related to like science communication, stakeholder engagement, and ethics. And so out of all the lectures, the one that really kind of caught my eye was talking about multiple ocean stressors. And so when I started my ocean journey, I started really learning. My background is ocean deoxygenation, so I can tell you everything about the loss of oxygen, right? And throughout that journey, I didn't really consider or input ocean acidification in that work until as I became a postdoc and really trying to see how these things interact. And our lecturer, Sam DuPont, presented a really interesting lecture talking about these multiple stressors. And so when you think about these ocean stressors, we got to think about them as like cumulative impacts, not just they're in silos, but how do they come together? Because this becomes important when it comes to creating solutions so that we can kind of have the marine environment that we all love and enjoy. And so some definitions that he pointed out that essentially sometimes get interchanged depending on what type of work you're reading. But it goes through the definitions for stressors, drivers, and stress. And that becomes kind of the foundation of really understanding and talking about what drives stressors and what causes stress and what are the drivers. And this becomes important for these solutions where you see on the schematics to the right. For us to have the solutions from the local, regional, and global scale, we have to understand what is our stressors, what are our priority lists, what is the things that are essentially causing impacts on the marine environment, and then kind of going up from local to the first row and thinking about, okay, how do we monitor the stressor inventory, but also like what are the research and impacts on this ecosystems? And this becomes essentially an up and down ladder cascade of trying to understand its impacts and solutions and making sure that we're still doing the things that need to be done. Going into piggybacking off of Denise's lecture, we talked about these stressors and pretty much the anthropogenic impacts that impact ocean acidification, or causes ocean acidification and hypoxia in the ocean. And one of the examples was the scallop fisheries that collapsed because of the coupled effect of marine heat waves and hypoxia. You can see this in this figure here. And so kind of switching gears into Malaysia, because we're there, and part of that experience is not just to come together, but also really to understand about Malaysia, the interaction when it comes to industry and the marine environment, and understanding what are the couple effects that are causing some of the issues and problems that are there. But it's not only just happens there, it happens all over the globe. And so when it comes to oxygen loss, which is something that is a really big problem in Malaysia, and we'll talk about that later when we go into stakeholder engagement, is that there are many aspects of drivers that are causing low oxygen in coastal waters in Malaysia. That includes sewage treatment plants, systems, agricultural runoff, industrial pollution, livestock, and sorry, gotta move this around, and wet markets, all contributing to nutrients that run into the ocean, contributing to eutrophication and the onset of hypoxia that occurs, especially during after monsoon seasons when there's an increase in precipitation in these environments. And so because of these impacts of low oxygen, it doesn't just affect marine life, it also affects the coastal ecosystem. And so we can see that in Malaysia, you have fisheries loss from mass diet fish deaths, aquaculture damage when it comes to lower profits, higher costs when it comes to managing and restoring these ecosystems, and tourism decline. And so as we're there, we're learning about all this stuff, and this is some of the stuff we're talking about. Now it's applying what you learn in lecture and from your own experiences to the field work in the laboratory setting. And so with the field sampling and laboratory analysis, we did a wide range of sampling, from boats, doing field surveys and transects, to doing nutrient analysis, and even working with fish to understand metabolic index and its impact from like heat increases in temperature to simulate heat waves. And so this is just some pictures I threw together. This is us out in the environment. The first picture you see to the left is just us, and it's kind of like marshy, low tide area where you have all these carpet amoeba. And so here we're doing some sediment coring, essentially for people that are not the science folks. You take a tube and you put it in sediment, and essentially you create this tube full of dirt. And this dirt becomes very important because you're able to understand what is the chemical gradient that's happening there, and the microbes that's there, or the animals that's there. And then this is kind of us going out into the different field environments, getting set up. This is us really kind of deploying different things. So you can see the picture to the bottom left is doing the sediment core. So you stick a whole tube in the sediment. To the top left is us doing this blue carbon incubation in these chambers. And to the right is us throwing this CTD, not a CTD, rosette, get my words confused, into the ocean so that we can kind of Niskin model. There we go. So we can measure, so we can get water quality samples so we can measure different nutrients. And so what did we do? So we went out and we essentially did a transect from the coast, from station 1 that you see on the left, all the way to station 6, all the way out to the open ocean. And we collected water samples. We measured for nitrate, we measured for temperature, salinity, density, and so on and so forth. And from that, we kind of plotted this figure. I will say that the data that we got from all the groups are kind of wonky because everything wasn't consistent, unfortunately. But part of this experience is us working together, learning about doing different things. There are many people that were on the boat that have never been on a boat, and they realized that that was their first time and last time to be on a boat because of seasickness. And so we went out and was able to measure different parameters. One of the key parameters that was important for us was oxygen. And so we saw that dissolved oxygen decreases as we kind of are moving closer out into the coast. And then when we went to another site, this is in Pulau Gazubo. Here's where it's low tide and we're doing these sediment cores, but also we're doing these transects where we're laying out this quadrant, this little square rectangle. And we're putting them out on a transect. And so we're doing this to measure what is the vegetation, the biodiversity that's there. And we're also doing sediment coring that's there because you want to make sure that as you're seeing whatever you're seeing out there, whether it relates to algae or seagrass or different animals, you want to make sure that you're also kind of capturing maybe the chemical gradient that's happening, especially in this area that has a frequent low and high tide pattern that occurs. And so what we kind of saw in our seagrass is that we saw high amount of algae coverage as we're going out from the coast all the way to the edge of the shoreline from our A and B transect. And we kind of are also seeing the loss of this carbon that is essentially locked up in the sediment, and then you burn it to kind of understand how much organic carbon that's there. And then last but not least, stakeholder engagement. So this is where we did a lot of engagement with locals, but the ones that that really impacted me was the aquaculture farms. So I've never been to an aquaculture farm. I've heard about it, read about it, people talk about it. It's an initiative, part of NOAA's initiative to include that, but never set foot on it. And so the video you see to your right is aquaculture farm that we went and visited right by the Marine Institute. And the backstory behind this is that before we went out there, we talked to a local fisherman, and he was discussing that with his family history, they went out, did traditional fishing, and because of nutrient and pollutions, it caused mass die-offs of fish, and that affected their income. And the son had to close down his fisheries. And so what he ended up doing was, well, I have to switch to aquaculture. And so he essentially built this aquaculture farm that you see here. And this is how he is pretty much pivoting from these impacts to kind of create a more localized area that he can kind of manage and control. We walked up and down, we walked up and down the planks. In each bin, there's some fish that's there. I don't remember all the fish that were there. We saw a few octopi that were swimming around. And so it was a really cool experience to really see this firsthand and have a better appreciation of aquaculture that's happening out here globally, really. And so conclusion, future goals, like it was said earlier, I'm a postdoc researcher. My research is looking at hypoxia and heavy metals and ocean acidification effects on red snapper. Coming up close to the end of my postdoc, so hopefully to kind of wrap this up and produce some nice papers. And so that is kind of like my future goals as the most immediate. But if you want to connect and collaborate or just want to talk about science, definitely reach out. And thank you.
Thank you, DeMarcus. That was awesome. What a great experience that you went through.
Thank you, thank you.
It seems like it was very pivotal in your career, and we wish you the best, for sure, for sure.
Thank you, and thank you for the opportunity.
Of course. All righty. Well, now we have Dr. Aurea Rodríguez. I will be having her presentation up. Dr. Rodríguez, are you with us?
I am here.
All righty. I will mute myself and share the screen. Well, let me do one thing at a time. Let's see.
Yeah, I'm going to turn off my camera because my internet connection is not so stable. So I'm going to shut my face off for now.
No problem. All righty. Can you see your presentation?
Yes.
All righty. Just let me know next slide when you want me to switch the slides, okay?
All righty. Let me set up something here for me. So good morning. Good afternoon. Oh, first of all, thanks for the invitation. It is a big pleasure to be presenting Taller Ecológico's first the Puerto Rico efforts in education about ocean acidification in the Caribbean. And we are presenting a changing Caribbean Sea, learning about ocean acidification. As Natalia said, I'm the founder, but also the director of Taller Ecológico de Puerto Rico. And next, please. It is very exciting to be presenting in this important day of action of Ocean Acidification Action Day. So it is a biggest pleasure and excitement to be here. Next, please. Next. Thank you. At Taller Ecológico de Puerto Rico, we are an environmental and scientific education organization. It was founded by me with a PhD in biological oceanography in 2017 after Maria. Challenging, hands-on experience learning, connecting communities, teachers, students, and general audience with nature. Everybody who wants to learn about marine science, environment, climate change is welcome to join our workshops and activities. We focus on marine science, coastal experiences, and coastal ecosystem, climate change, but we also do other workshops. And let me change this because I'm not sure if it's okay. I was feeling that it was unstable. The most important thing about our experiences is that we provide experiential learning mostly in nature, and participants can relate with topics in real settings. Well, during pandemics, we had to reinvent ourselves and created online courses and webinars, which fortunately were very successful. Next. We promote highly quality environmental and scientific education, and I stress highly stressed scientific because we use the science and we show the science in a very simple way to students from different ages. We foster environmental awareness and critical thinking, inspire conservation of marine and coastal ecosystems, and our activities include workshops, field experiences, seminars, webinars, summer camps, and STEM programs. Our programs integrate hands-on learning, teacher training, and community integration and outreach. We serve students, educators, teachers, communities, anyone who wishes to take our workshops and learn and be aware about all the issues is welcome. Our aim is to disseminate information and translate data and the science from other projects, and also to promote awareness of the importance of government support in coastal management, so people know what they can ask for also to their administrators. Next, please. Our impact from 2017 to 25, we have impacted many teachers, fishers, and communities in general. Sometimes we have families that are interested in having our workshops, and we do that. We integrate education and awareness about ocean acidification in all our efforts, in most our efforts, especially during experiences. We advance ocean acidification education across the Caribbean region, and we have partnerships with NOAA, CARICAN, for example, NSF and NASA, Oceanos, that I will talk more about these projects in next slides. And these are funded initiatives from local agencies. We have with the Department of Natural and Environmental Resources, the Department of Education, and other regional institutions that helps us strengthen the OA literacy in the Caribbean. Next, please. In the next slides, I'm going to show you some of these education projects and collaborations where we integrate and help to make awareness of the ocean acidification topics in Puerto Rico and the Caribbean. Next, please. Taller Ecológico has a nice collaboration, and this is deep to my heart, with the Jovaner, is the Hobos Bay Natural Estuary Research Reserve, with a program called Teachers on the Estuary. From 2019 to 2025, we have been working in this project. Even during pandemics, as I said before, we had to reinvent ourselves and use the online tools to keep working. We are the general coordinator for training, supporting environmental literacy and capacity building for the TOAD program at Hobos Bay, at Jovaner as we call it. The TOAD program is a NOAA-supported initiative offering research and field-based professional development for K-12 teachers. We have impacted from 2019 to 2025, 110 teachers. It could have been more, but with the pandemics, we had to stop for a while, but then we began to do it our workshops, and we even did some workshops we on the field and teachers online. So it was a very big challenge for us to be doing that, but we did it. We made it and we survived, and it's thriving, so it's very good. Teachers from all the disciplines are invited to this program, so you don't have to be a science teacher. And it has a broader impact because not only the teachers that actually directly take the workshop, but they are invited to bring this to school, share it with their colleagues, and also bring the students to the reserve. So the reserve is as a natural laboratory for them. So this has a very broad impact, and it has been a very successful project. And the ocean acidification topics is integrated in these workshops, and this is very important as coastal acidification is significant in estuarine zones. Next, please. We another activity that this began before Maria. This was the first activity that Taller Ecológico program, and is a hands-on summer educational program designed to immerse students in environmental and marine science through experiential learning in natural settings. So it's all in the field, beach. We take people to laboratories and they have contacts with real scientists. And we have impacted 160 students from 17 to 25, ages 8 to 17. And during pandemics, we had a 2 weeks online summer course that, interestingly, it was very, very successful. And then we had students when the pandemics, were opened, when it was open again. So we took many of these students that were online, were interested in coming presentially, and actually some people from the States. So it was very interesting that they were online, and then they were really excited to come to Puerto Rico and share their experiences in real life. And we, in Verano Ecológico, we integrate the ocean acidification topic very seriously. And we have, as I said, students from ages 8 to 17. So we try to make it simple, and we integrate activities. Next, please. We integrate, actually, we do this with teachers and even older participants. It was supposed to be a video, but we had problems. I'm gonna show you that we have water, we have vinegar, and we have a soft chalk. So we put 2 pieces on each beaker, and you see the dramatic effect of vinegar on the chalk. We explain about how the calcium carbonates organisms are affected by the acidic conditions. I try to explain in a simple way that how you feel acid, like to kids. I say, well, this kind of when you have lemon, that you feel that tingly sensation, and that thing erodes the organisms, and it's a very nice thing. Next, please. Another program that is been actually big, very big, is the NASA Oceanos program. TPR is a partner in the NASA. It's called Ocean Community Engagement and Awareness using NASA Earth Observations and Science for Hispano-Latino Students, or Oceanos initiative. This seeks to increase oceanography and STEM opportunities, especially ocean science exposure for Hispanic Latino students in Puerto Rico. Actually, the priority is for the public education system students, and it focuses on paid summer research experiences and community science engagements. This is for student, high school students. We have had 37. Also, early stages college students, we have had 37 so far. And teachers, we have engaged, excuse me, we have engaged teachers too, and we have had 21 students. And this is a very big and successful program that TPR works on the logistics, organization, training. So we like it. And I think this picture shows, like, I don't know, the essence of our project. Next. In all those projects, of course, we want to stop a little bit. We integrate the ocean acidification program, and especially I'm a plantologist, so I integrate the issue of ocean acidification in plankton, and we work with collars in oceanos, so we also show and make awareness of the problems of ocean acidification with plankton and coral reef ecosystem. Another project that is a big one and is in process is the climate change mitigation, adaptation, and resilience plan for Puerto Rico. This plan is a mandate from the Law 33 from 2019. It establishes also the Climate Change Expert and Advisory Committee that happened in 2019, because that's the mandate of the order, is to create that committee and to make the plan. They made in 2021, they made a vulnerability assessment and public consultation workshops to address the risks, the objectives, and outline the plan. It was created. The draft was published in 2022, and also in 2022 it was submitted to review and to update the plan. It is still pending for executive government review and approval. So this is a very big project for Puerto Rico. The plan is a comprehensive science-based framework developed to address the impacts of climate change across the island. This plan identifies Puerto Rico primary climate risk, including ocean acidification, and it outlines the strategies to reduce vulnerability and strengthen long-term resilience. And next, please. The structure of the plan is complex, actually. It's very complex, but I'm going to simplify here the part of the marine ecosystem and coastal zones. The director of Taller Ecológico, or me, I was the technical specialist for this section, section 4.8. The first part shows the climate stressors that threaten the ecosystem, the risk as warming ocean temperature, ocean acidification, sea level rise, stronger storm, coastal development. So it addresses the issues and the state. Actually, the first volume stresses how it is, what is the problem, what are the risks, and then there are what is called, in planification terms, courses of action, and two of the big courses of action suggested in this plan are to expand monitoring research, support long-term monitoring of ocean chemistry, biological responses, and local drivers of acidification in the Caribbean, to inform management and adaptive decision-making, and integrate ocean acidification into coastal and marine management. These efforts are initial steps to educate and take action in the face of ocean acidification. This plan is developed for the agencies. So the president of the committee is the Department of Natural and Environmental Resources Secretary, and it's still under revision. And I say it's a big one. If anybody wants to read it, you can contact me to try to understand. But first volume is how things are in the coast, is in this chapter, and what should we do with strategies, objectives, and who should do it. So it's a very, very broad plan that we hope that is approved. Next, please. Another collaboration that Taller Ecológico is working on right now is with the Caribbean Fishery Management Council. This project is called Understanding Impacts of Extreme Events on the Fishery Ecosystem and the Fishers Community in the U.S. Caribbean. This project seeks to strengthen the council, as we say, the Caribbean Fishery Management Council, outreach and education efforts to enhance understanding of extreme events, including ocean acidification, and their impact on fishing communities to improve adaptation strategies and sustainable solutions. This effort is combined with a storybook that is developed as the foundation for a series of workshops with fishers and teachers. This project is led by Consultores Educativos Ambientales, that is founded and directed by Dr. Alida Ortiz, a leader in marine science education in Puerto Rico. It is a beautiful, vital effort to address ocean acidification awareness and education for fishers and educators. At the workshop, it is very interesting because we have talked to them, we take their input, we make activities for them to understand in simple ways what are the concerns they should have in ocean acidification, and also for teachers to bring this to students, because ocean acidification is something you don't see. Like, it's hard to understand if it's something that you're not seeing every day, right? Next, please. A very exciting collaboration that we recently initiated is with the CARICAN, and we search to strengthen education, awareness, and engagement efforts in the Caribbean regions. With the Coastal Acidification Network, we can boost significantly education engagement by facilitating data sharing, providing accessible education resources, and fostering community involvement. We hope that this is the beginning of a very productive collaboration in awareness and education and engagement, of course, of ocean acidification in the Caribbean. Next, please. As I said before, Taller Ecológico is an organization that we share information and data and the science of other projects. We aim to disseminate the information and bring that to people, even science data, and we present the buoy that is in La Parguera. This buoy presents data on CO2 concentration in the air and CO2 in the seawater. This buoy data is accessible on the PML, that is Pacific Marine and Environmental Lab webpage. Here you can access plots of surface water, atmospheric CO2, as I just said, surface water pH. Preliminary and non-curated data is also available in the CARICUS portal map, CO2 dashboard, and this is a unique instrument and tool in the Caribbean. The data is you can find it in the portal in real time, and so here you can see the map where the buoy is located in La Parguera, in Cayo Enrique, and here you can see the buoy. It also measures dissolved oxygen, chlorophyll, turbidity, sea surface temperature, salinity, and barometric pressure. Next, please. Oh, I was discussing the previous one. So here is where you can see the plots, and as you can see the real data of CO2, the concentrations in La Parguera in the air, but also in seawater. You can see the plot, you can access them, and you can here see the portal, the CARICUS portal. So if you want to explore the data, you are welcome to come and share. And this is also a partnership with the map. I need to familiarize with the names. It's a more autonomous PCO system. So this buoy is there in La Parguera, is more, and you can find the data and the products on the CARICO's webpage. Next, please. So our takeout notes. Ocean acidification is an increasing threat to ocean and coastal systems with potential environmental and socioeconomic impacts. And addressing this issue and expanded understanding requires wide range education efforts targeting the public, fishers, resource managers, agencies, decision makers, and other sectors. These partnerships that we are making, and we are hoping for many more, are crucial for linking science and actions to safeguard our oceans for future generations in adapting to a changing Caribbean Sea. Next, please. Now I want to thank you for your attention. If you have questions, I'm more welcome to do so when Natalia says so, when the boss says so. And this is my contact information and the Taller Ecológico webpage QRs. You are welcome to come in and see the projects that we are doing there. Thank you.
Thank you, Dr. Rodriguez. It's really nice to see how much the Taller Ecológico has grown.
Thank you. You've been a big part of it too.
It's a wonderful project, and it deserves recognition. So I'm very happy that we were able to provide this platform for you to promote and talk about it as well. All right, and with that, we are open for questions from the public. Please, you can type your questions in the chat box. So I'm gonna give it just a couple of minutes for the people to write some questions if there's any from the audience. Now it's your turn to talk. Speaker is so good, everybody's speechless. Well, I will break the ice and maybe get some gears turning for questions. So I do have a couple of questions here. So for the speakers, what is the main barrier to understanding ocean acidification? This is a really good question because, for instance, us that we're at the at the Coastal Acidification Networks, one of our biggest goals is to provide community outreach and engagement. And that includes from K to Gray, or, and some of these concepts are kind of hard to digest. So from both of your perspectives, like, what do you think is the main barrier to understanding ocean acidification? Let me see. Wait, you're muted. There you go.
Okay. Yeah. So thanks again for the invitation. So as I work with various age groups in my workshops, so I see it's a hard science to understand ocean acidification. So the main barrier is also that you don't see it. So it's something that you don't see. You don't see it every day. Actually, when the water is warm, you go to the beach and you feel that it's warmer. you feel the hotter air, but the acidification you don't see, it's something very subtle. So first of all, is teaching the science in a way that people can understand it, to people that are different ages. So showing the science, showing the data, so they can see, the real facts. And with that, then we can go to awareness and engagement. So first steps are definitely educating about the science, and in different ways, depending on the group and on the actors that are here. But mainly that you cannot see it. Thank you.
I'll also echo that as well, because from the science standpoint, the concept of ocean acidification and all its processes and how to measure it is it can be convoluted sometimes, and not every place has the ability to measure ocean acidification in that way. And then if you're talking to somebody that's a fisherman or in fisheries, they're more than likely probably worried about immediate impacts that's going to happen in the next season or next couple of months, where ocean acidification is kind of a long-term effect. And so really thinking about what should I put most of my emphasis and understanding in, it may be a disconnect between the scientific community and our awareness and wanting other folks to be aware of it versus folks that are directly involved in the maritime industry.
I also have a comment that this is for the Caribbean. So in other areas, in other regions, ocean acidification is being more made aware because of shellfish fisheries. That is an very high economic source in some countries and states. For here, so it's kind of more subtle, and we need more research and more monitoring to understand it more. So in the Caribbean, we have other situations, and we need to make it more aware.
So we have a question. Erica Young asks, what activity do you both do that essentially makes ocean acidification click?
Oops, sorry.
I can go ahead. So I guess in my past activities, I've done community engagement events, so similar, where I've had groups of like K through 12 kids, really just a younger group, and we would talk about ocean acidification, but in the context of, and I don't do it that much anymore, but like if you take some eggshells and you put it in some water, you take some vinegar, you can kind of see it dissolving on the shell. You can have a conversation about like, what does this look like and what is, and you can kind of show the shell afterwards and see that it's more brittle, and it dissolves. I don't do that as much because people have egg allergies, and also it's not really great just going around breaking eggs. And so that's one activity, or just one activity. Another activity I did actually took a very long time, which is taking a straw and blowing air into like a beaker of water. But and you take some strips and you kind of measure it. But that was almost like an entire day process. And so, and the change was subtle. And so from a early childhood point of view, that's what I've done in terms of just trying to communicate it to the younger generation. Unfortunately, I haven't had that much experience to do it with other older adults and people that are actively engaged or just want to know.
Yeah, so I make the dramatic experiment with the chalk. That is very, it dissolves. The chalk begins to dissolve in your own eyes with the vinegar. So if anybody's interested, I can send the video. And it's very dramatic. And of course, I explain that it doesn't happen that fast. That is not something that you see like that, but it's a dramatic effect. Let's say if you put it in fast forward, so you can do, it's something like that the chalk starts dissolving really fast. But the eggshell experiment is something that I have done, but it takes the time. It's something that you have to live a week. So with the summer camp, we can do that. but not in like small workshops, like 2-hour workshop. But yes, it's for them to see. And in my experience, I haven't done it itself. Actually, this is an idea to do it next summer. I collect a lot of shell plankton, let's say gastropods, in many samples. So I'm planning to put those that are very delicate in an acidic environment and monitor like for a week and students and see what can students see.
Thank you. We have another question. Do you guys have any idea or ideas on how to integrate this topic in curriculums, education curriculums? And if you do, at what level would you introduce it?
Brad, you want me to answer? Yeah, so I'm planning to integrate, as I say, in the summer camp, that this is from ages to 8 to 17, but also with teachers and having an idea for them to use the data. For the TOED workshops, the TOED program, we teach them to use NOAA real data to use it for projects on their classrooms and different levels, different ages, like let's say elementary, middle, and high school. So I'm planning to bring this data for the boys, for example, so they can use it for project-based learning projects.
And I don't know.
And now I'm really excited about the CARICAN collaboration. I'm sorry. Sorry, Robinson.
DeMarcus, do you want to say? Yeah, go for it.
So I started to do this. I'm not sure about it being a part of a curriculum. Maybe in the future, if I become a professor or somebody wants to use it. But I became a carpentry instructor last year because I really wanted to teach kind of data science and R, and so I started to put together this marine science for R, kind of like curriculum thing. And one of the things that I started to really get engaged with is some of the packages and all of the data that's there. So I talked to some people at AOML, and they provided me with some resources to look at different hydrographic measurements and kind of utilize that for students to really get into data science and computing and really have really good questions based off the observations they're seeing. And so that's something that I slowly started to do this past year. But I think this is a very important question. I actually had an opportunity to talk to some people out in Louisiana about 2 years ago, and we were talking about ocean and educational stuff, and I was doing this same webinar, not in terms of ocean acidification, but just my journey. And one of the things that was kind of eye-opening was that just because they're in Louisiana doesn't mean that they get engaged with ocean education. And so there's kind of the gap with just that general, having that thing as a general topic in K through 12 education, let alone a specific topic like ocean acidification.
Thank you for sharing. I do want to share that we have 1 minute left, but there are a lot of questions. So if by the hour you need to, for any reason, leave, let me know. But we have a couple of more questions. But if you have to leave, I understand, and that also applies to the speakers. I can also send you these questions later. But we have a question. We have a couple of questions. So here is like, how do you feel the literacy around ocean acidification has changed in your respective communities in recent years?
Want to start, Marcus?
Sure. Good question. I guess for me, truth be told, I actually haven't really watched and see the literacy change in ocean acidification in my community. I've seen it become more talked about in general marine science spaces. And then as you can start to engage with other people, it seems like it's still kind of relatively the similar topics and whatnot in terms of these are what's happening. We still need more monitoring. We still need more research to investigate. There's still gaps in understanding. And so it seems like, at least from my observation, things are kind of a steady change, but nothing that's like truly significant when it comes to talking about ocean acidification, talking about solutions, and talking about what to do next. And also, I do have to jump at 1 o'clock. I would like to stay, but I can't.
Yeah, I can say a bit.
I was about to say it was a great opportunity. I really appreciate it, and hearing you all's talks, and really appreciate it. And hopefully everybody that's still here get engaged and definitely reach out, and hopefully you walk away with something that you learned. You guys have a good rest of your day.
Thank you, Dr. Robinson.
I can answer quickly about my experience. So teachers, or at least the one that I get in my projects, they are very interested in the ocean acidification topics and issues, and they want to learn to bring it to their classroom. So I think there is a questioning about what it is, and actually they do want also to know how to bring it to their students. So at least now you hear about it. I think it's really important, because now I feel that it is heard. It is heard that this is happening, that this is an issue, and that we should learn, and we have to keep bringing the importance of it, and bringing the importance of the awareness, and what can the consequences be if we don't understand and act on this. So in my environment, in my workshops and work, I feel it is the awareness is increasing. I mean the curiosity is increasing in the general public.
Awesome. Yeah, there was a ocean acidification week in October, and there was a presenter that mentioned that in France, the way to engage people is to help them, make them care. And a lot of people are interested, right, in the food, like you were saying, like shellfish fisheries and red snapper in the case of the Marcus. But this person, if I recall correctly, said that there was an experiment performed, or there's been studies performed in France, where acidification changes the flavor of shrimp, which is super interesting to me. And I wonder if there are other studies that could be done for other commercial shellfish species, or even fish, if that acidification changes the flavor of, or the quality of the, for instance, oysters or shellfish, right? There was another question, says, this is John Mayman, and he says, I work with an organization in New Jersey, I'm gonna butcher this name, Barnega Bay, similarly focused on education of students, the public, etc., on the remarkable resource that is our bay along the U.S. Atlantic coast. And it says the Reclaim the Bay is also studying and supporting research on the impact of climate change and OA on our ocean-bay waters. Dr. Rodriguez's example using chalk in the water and vinegar, relating it to the impact of shellfish, is brilliant. Are there other similar examples to illustrate ocean warming, impact from carbon or CO2 buildup, eutrophication, etc.? And I open this question also to our other panelists, our other CAN network coordinators. In my experience, the experiment that the Marcus has performed with the straws and the bubbles, I've done it with a pH meter rather than a pH strip. So real life, they can see as like how the pH decreases with the increase of CO2 when you blow bubbles. I've also done it with magnets, where you draw out water and seawater, like in molecules, but using magnets. So you teach them how the reaction happens. This happens here. This is how we form bicarbonate. And then they realize that they don't have enough calcium carbonate to do bicarbonate. But that's just more visual in like a puzzle piece where the molecules are like a puzzle. But it takes more. I mean, this was made in like a Clearwater Aquarium Science Festival, which was very low volume of people. So I think that doing the outreach part, it has to be something that is quick. So the chalk is, I think, is excellent because it's quick, it's visually impressive, and I think it happens in real time. Whereas if you have like shells in different, like carbonated water, vinegar, seawater, tap water, it's a more gradual change. So if you're multiple days, you can leave it in the beakers and see it. The other one that I've seen is I think it's red cabbage juice. It's a natural pH indicator, and you can see the color changes as you add different components.
Yeah, if anybody has ideas, please share them so we can work as a group to increase this awareness.
There are some resources on the GCAN webpage as well. There's some curriculums. Dr. Liliana Freites and Dr. Lorraine Martella have done some ocean acidification literacy projects that are very well thought out and organized. We have, it says, thank you for your responses. Didn't know about the shrimp flavor changing. No, me neither. It was very interesting it actually blew my mind, and I started thinking about potential projects that could be done, in different areas. I think it's everybody who eats shellfish will be interested in knowing if the quality or flavor changes. And then I think we have one more, one last question is, what variable of climate change is the most responsible for ocean acidification?
What, can you repeat the question?
What variable of climate change is most responsible for ocean acidification?
Well, pH. So I think it's in the same. So pH. Yeah, and particulate CO2. That is the measurement that these scientists made in this project. That the buoy that is measuring that. So those are the indicators used in these projects.
Yeah, CO2 emissions changing.
He's around. I don't know if he's around.
Who?
Dr. Morel. I don't know. Carico's director. I don't know if he's around. So
he's around. He was online. He's online.
I don't know if he wants to answer more about that.
Well, I would leave it at I would leave it there. I think that's pretty much the correct answer. It's very interesting. It's also like a loaded question, right? Like variables of climate change. I think like when we talk about marine heat waves and the combination of ocean acidification, it's hard to separate what issues are responsible, because some things can intensify others, and it's just like a ripple effect. So I think it's a really valid question. And I think it's more complex than just saying like I think that the answer is yes, the CO2 emissions increase and the changes in pH. I think that's like the surface level, but if we go into the rabbit hole, it's a lot more complicated than that. But I think that's the efforts that we're doing, and as everything, we need more research. And I think in order to do research, we need people that are interested, and to get people interested, we need people like Dr. Rodriguez and Dr. Robinson, and the people that are in this call that, we start by educating others. And I think that is how we start taking action towards ocean acidification. So with that, I would like to thank again Dr. Rodriguez and Dr. Robinson and my colleagues at the Coastal Acidification Networks, NOAA Ocean Acidification Program, and the IOS program as well for helping me host this webinar. Please be on the lookout. The Gulf Acidification Network has a calendar of events in their website. And feel free to contact us through our web pages, and also Dr. Rodriguez, if you want, I'm gonna share with the QR code one more time. And this concludes our webinar.